Hello everybody, welcome back to another segment. We are looking at June examination grade 12 paper number 2 in technical mathematics. So yes, let's get into business. Question number 1, they say in the diagram below, A, B, C, and D are the vertices of a quadrilateral, and then they say E, it is the midpoint of CD. Determine the length of AB. Before you can determine the length of AB, identify the points. The coordinates of A is 0 and 4. The coordinates of B is -7 and 0. Label your coordinates as x1 and y1. This one is x2 and y2. Then determine the length. The formula is in your formula sheet. Call this x2 minus x1 all squared plus y2 minus y1 all squared. And then you do your substitution. What is your x2 is -7 minus 0 all squared plus what is your y2? It is 0. You say minus 4 all squared. Then it's a work of a calculator here. The answer is going to be the square root of 65. Leave your answer in set form according to the instruction of the question. 1.2, it says determine the coordinates of E, the midpoint of C and D. So the coordinates of C, firstly, this is 1.1, this is 1.2. The coordinates of C is -5 and -4. The coordinates of D, it is 3 and -2. Label your points again. You're gonna have x1 and y1. You're gonna have x2 and y2. So the coordinates, midpoint using the capital letter M of CD. The formula is also in your formula sheet. x1 plus x2 divided by 2. y1 plus y2, you divide that by 2, and then you do your substitution. What is your x1 is -5 plus 3. All of this is divided by 2, and then -4 minus 2, or you can just say plus into minus 2. All of this is divided by 2, and then M of CD, 3 minus 5, or rather minus 5 plus 3 is going to give us -2, and -2 divided by 2 is going to give us -1. Use your calculator, guys. Also, this one you can put it in the calculator as it is, and then you will see that it is going to give you -3. Therefore, the coordinates of E is going to be -1 and -3. Use your calculator. So this is 1.1 and 1.2. 1.3, determine the gradient of AD. The gradient of AD, the coordinates of A, again, it's 0 and 4. The coordinates of D, it's 3 and -2. Label your points, x1 and y1. This is going to be x2 and y2, and do your substitution. The gradient of AD, the formula is given by y2 minus y1. You divide this by x2 minus x1, and then you substitute. Your y2 is -2, your y1 is 4, and then you divide that by x2 is going to give us 3, and then x1 is going to give us 0. Put it in your calculator. -2, -4 is going to give us -6. Divide everything by 3, you're going to get -2. So this is your gradient. 1.4, determine the size of beta. This is the angle in question. The formula that we are going to use is given by the tangent of beta equals to m, which m, this angle is on the line of AD. So we're going to use the m of AD. M of AD is this one that we just calculated. So we're going to have the tangent of beta, it is equal to -2. Then what you're going to calculate here is your reference angle. Your reference angle, you're going to say the arctangent of 2 This is going to give us, you put it in your calculator, it's going to give us 63,4349. I'll just keep it up to 4 decimal place there. This is our reference angle here. It's not the answer. Therefore, what is beta then? Beta is going to be 180 degrees minus 63,4349, where beta then it is equals to 116,57 degrees. Somebody can be asking, why are we saying 180 degrees minus the angle? If you look at this, it's an obtuse angle. Remember, you've got an acute angle, you've got a right angle, and then you've got an obtuse angle here. An obtuse angle is greater than 90 degrees but less than 180 degrees. So whenever our angle it is open like this, we know that it has to be greater than 108, it has to be greater than 90 degrees but less than 180 degrees. And at the same time, our gradient here is negative. So if our gradient is negative, I am expecting my angle to be greater than 90 degrees. All right. So 1.5, it says determine the equation of the line AD. The line AD, determine the equation of the line AD, this one here. Okay, already we have the gradient. So the gradient of AD here, it is equals to -2. Then you can take any of the 2 points, either these ones or these ones, to help you to determine the equation of the straight line. So y minus y1 equals to m into x minus x1. So I'm just going to take these ones here, where this is my x and this is my y. So I'm going to have y minus -2. It is equals to -2, which is my gradient, into x minus 3. This one is going to be y plus 2 is going to be -2x plus 6, and then you transpose. Y is going to be -2x plus 6. Okay, let's just write that, plus 6 minus 2. Therefore, the final equation becomes -2x plus 6 minus 2. 6 minus 2 is going to give us 4. And that brings us to the end of question number 1. Let's see what we can do with question number 2.